0 to infinity dx divided by x power 3 plus 1 over x power 3 whole square. To start to solve this problem, we multiply. This is one solution. There is another solution. There are another solution. Multiply the numerator and numerator by x power 6. The integration will be I equal integration from 0 to infinity x power 6. The denominator will be x power 6 plus 1 whole square. Multiply the numerator by 6 and divide by 6. To solve this integral, we'll use integration by parts. D R x plus 6 x power 5 over x power 6 plus 1 whole square plus minus 1. The integration of this will be minus 1 over x power 6 plus 1. This integral will be I equal 1 over 6 x multiplied minus x divided by x power 6 plus 1 from 0 to infinity plus the integral from 0 to infinity dx divided by x power 6 plus 1. This term will be 0 at x infinity. This will be 0 at x 0. This will be 0. So this term will be 0. The integral will be reduced to be I equal 1 over 6 integration from 0 to infinity dx over x power 6 plus 1. Let x equal 1 over u. Dx equal b minus u power minus 2 du. Substitute at x 0 u equal infinity. At x equal infinity, u equal 0. So I will be integration 1 over 6 integration from infinity to 0 minus u power minus 2 du divided by x power 6 equal u power minus 6 plus 1. Equal. The limit of integral will be changed according with this sign. I equal integrate 1 6 integration from 0 to infinity u power minus 2 du divided by u power minus 6 plus 1. multiply the numerator and numerator by u power 6, this integral will be I equal 1 6 integration from 0 to infinity u power 4 du u power 6 plus 1. For the same limit of integral, we can replace u by x. I equal integration from 1 6 integration from 0 to infinity x power 4 dx divided by x power 6 plus 1. For the same limit of integral, we can replace u by x. So we have two integrals. First one equal integration 1 over 6 integration from 0 to infinity dx divided by x power 6 plus 1, and the same integral equal 1 over 6 integration from 0 to infinity x power 4 dx divided by x power 6 plus 6, i.e. 2I equal 1 6 integration from 0 to infinity x power 4 x power 4 plus 1 over x power 6 plus 1 dx. I equal 1 over 12 integration from 0 to infinity minus x squared plus 1 plus x squared over x power 6 plus 1. I equal 1 over 12 integration from 0 to infinity x power 4 minus x squared plus 1 over x power 6 plus 1 dx. Plus integration from 0 to infinity x squared dx divided by x power 6 plus 1. I equal 1 over 12 integration from 0 to infinity. By analysis of this, it will be 2 cubic, sum of 2 cubic, x power 4 minus x squared plus 1 divided by x squared minus x power 4 minus x squared plus 1 multiplied x squared plus 1 dx plus integration from 0 to infinity x squared dx divided by x power 4 x power 6 plus 1. So this integral will be reduced. I equal 1 divided by 1 over 12 integration from 0 to infinity dx over x squared plus 1 plus integration from 0 to infinity x squared dx over x squared x power 6 plus 1. Multiply the numerator by 3 and divide by 3. I equal 1 integration from 0 to infinity dx over x squared plus 1 plus 1/3 substitute x cubic equal t. And the differentiation 3x squared dx equal dt. At x equal 0, t equal 0. At x equal infinity, t equal infinity. So this integral will be from 0 to infinity dt divided by t squared plus 1. I will be 1 over 12. This integral will be inverse tan x from 0 to infinity plus 1 over 3 tan inverse tan t from 0 to infinity. I 1 over 12 by over 2 plus 1/3 by over 2 equal, this is equal 3 by 6 plus by over 6. So this integral will be I equal 1 over 12 multiplied, this is equal to 4 by 6 multiplied 1 4 by 6. One 3 I equal by over 80. Finish. There is another solution for this problem later.